Hello, this is Eric Moreno and Alan Sager talking about our final project for ergonomics at Kettering University. For our final project, our team decided to go to Eldermans Incorporated, which is an agricultural repair shop, and do an ergonomic analysis of the removal of the feeder housing for a combine. At this repair shop, there are no repetitive assembly tasks like you will see on an assembly line. The tasks happen on a need-based level depending on the job.
After seeing how the mechanic hammers the feeder housing drive shaft out of the mounting bracket and how they pull the feeder housing onto the fork of the high-low, we concluded from an ergonomic viewpoint that these tasks can cause potential risk to the mechanic. Tasks are conducted in an 8-hour shift with one break consisting of a 1-hour lunch. The frequency of this task is twice a shift if they are working on this type of repair. In the following video, the tasks are conducted with 2 workers, but in normal working conditions, it is conducted with 1 worker.
As you can see in this video, the worker has to offset their stance for balance and swing the 15-pound composite sledgehammer and strike the drive shaft onto the feeder housing. After the drive shaft is broken free, the mechanic has to straddle the high-low fork as shown, and then pull the feeder housing assembly with a jerking motion to pull the housing onto the forks. In order to perform an accurate assessment of the task, first we use the ruler tool to determine if the tasks analyzed have any indications to be hazardous or dangerous to the worker, and followed by using a 3D SSPP tool to recreate the postures of the workers during each of the tasks and see the capabilities of the workers.
After analyzing the tasks, the team determined the most notable risk factors. For the hammering task, we noticed that the worker could potentially pinch his lower back depending on how much he twists his torso while swinging the sledgehammer. In addition, the vibration produced by the hammering is absorbed by the forearm and wrist, which in the long term could lead to a cumulative trauma disorder. A snippet of the hammering task is shown on the side. It can clearly be seen by the 3D SPP that this task represents risk on most of the upper body. The following figure shows the 3D SPP analysis of the hammering subtask. As it can be seen from the results, this worker does not have the capabilities in their wrist, elbow, shoulder, or torso to perform the task. It can also be seen that the lower back compression shows warning signs. We performed the same method to analyze the pulling task. As it can be shown in the roulette results, the task was a pretty high score, which indicates that the task is not completely safe and rework needs to be done. While performing the 3D SPP analysis, we can see that this task is safer than the hammering based on the fact that most of the worker's limbs are in acceptable levels regarding its capabilities to perform the job. A zoom on the data results of the 3D SPP analysis on the pulling task can be seen above. While some of the limbs are not capable of performing the task, the lower back compression is within good parameters that show no sign of exposure to hazardous activities.
After conducting the analysis of these tasks, it is our recommendation that Aldermans Incorporated implement an electric winch system to remove the feeder housing drive shaft. This would consist of a mounting assembly being built and attached to the mast of the high-low. This will then allow the mechanic to attach an electric winch to the high-low. The operator will then position the high-low in position like they currently are doing, and they would attach a strap from the housing pulley to the winch hook. Then, with either the quarter controller or the wireless controller, the worker will activate the winch while standing in front of the feeder housing. This allows the worker to spray the drive shaft with lubricant and remove the bushings at the same time. By switching to a winch system for a total cost varying from $289 to $342, depending on if they buy a wireless controller, Aldermans will be able to conduct this repair quicker than was previously done with one mechanic, while eliminating the risk and limitations that were seen with the analysis of the hammering and pulling task. From the rule analysis for this job, the worker is at level 4, which is a marginal warning level. Since the worker is not conducting any effort besides pushing the winch button and removing bushings, this task is deemed acceptable. Based off the 3D SPP for picking up the winch, the task can be conducted by anyone without any lower back strain.
The same can be said for the 3D SPP for the pushing of the winch into the mounting bracket. Over 95% of workers can complete this task, far exceeding the level of workers that were able to conduct the hammering and pulling as stated in their corresponding 3D SPP. The balance is unacceptable in this posture, however. In conclusion, after having analyzed the subtasks chosen and listing potential recommendations, it can be seen that by making a relatively small investment on an electric winch, one of the subtasks would be eliminated and the worker would not need to perform any pulling or pushing activities that would produce strain. This solution would also help to increase productivity as the worker would not have to move from one end of the housing to the other. In addition, this solution can also be used for different tasks that involve moving heavy parts.
We hope that this analysis is of use to Aldermans and its employees. The team would like to thank Aldermans Incorporated for allowing us to access the facilities and gather the necessary data for our project, Brad Hurd for coordinating and arranging the visit to the facility, and Professor Justin Young for facilitating the completion of this project.